This lesson deals with supplemental problem 210. You can find this problem in the ECE302 ebook in the Chapter 2 Supplemental Problems on page 22. This supplemental problem, I'm going to model some different light-emitting diodes, and I grabbed the data off of the web, and the reference is at the bottom of the page. It was electronics-tutorials.ws and subdirectory of a diode. And it gave me a lot of values for the drop across a LED for different types of materials, and then the value of the voltage at a specific current. Light-emitting diodes are p-n junctions of gallium arsenide or other compounds, and all these materials have the property that whole electron pairs generate photons of a single principal wavelength upon recombining. The spectrum of light is usually dominated by a single color. The equation for an LED is the same as any other diode. It's a Shockley equation. So there's a value of eta and I sub s. On the website, they listed different materials, and then again the drop across the p-n junction. This is gallium arsenide phosphide, and it's able, with doping, to create a red or an amber color, and the drop across it is similar. It's a little bit lower for red and a little bit higher for amber. This is the same material, but it's doping it with nitrogen. They're able to get yellow, and the drop is about 2.2 volts at 20 milliamps. This is aluminum gallium phosphide, and it can create a green color with a drop of about 3.5 volts. This is silicon carbide. It can create a bluish color, drop about 3.6 volts at 20 milliamps. And then this is gallium indium nitride. It generates a whitish color with a drop of about 4 volts across it. If you want to model these, just like we showed in our class notes in Chapter 2, it's an ideal diode in a battery, and the battery is these values that we found or measured. So for red, it'd be 1.8 volts, for amber, 2 volts, for yellow, 2.2, for green, 3.5, for blue, 3.6, and for white, 4.0. And this is supplemental problem 210.